Alright, this is also one of the type of question that involving implicit differentiation here. So this is an implicit function. So as you differentiate this one for first derivative, second derivative, you are getting this second order, the second order derivative function, right? Second order differential function. So now this question is asking you to, from this, you have to prove that you're getting this thing, right? So of course you need to differentiate this one for the first time, the first derivative. So differentiate this one with respect to x for the first time. So now I'm going to differentiate this one. So I have 2x, right? So differentiate y squared, you have 2y dy dx, right? Very simple here, right? The difference between these two is this is y, so that's why you're adding dy dx. And differentiate this one also, but you must know that this is x multiply y, it's a uv, apply product rule. So u v prime plus v u prime. So u x y, differentiate y. So dy dx plus with v is your y, right? And x is 1. Yes or not? So y1 and x dy dx. So I group all the dy dx together where 2 dy dx, right? So or I can rewrite as this form, okay? I can rewrite. So because I see that I always prove something based on what I can see here, right? How I arrange this based on what I need here. So you see that there is a x minus 2y here, right? So I very sure that I'm going to bring this go over there because you were getting x minus 2y here. So this is what I believe. So okay, that's why I continue to doing as. So I writing this whole thing to be x x dy dx minus positive negative 2y dy dx, right? I bring in everything go to the other side, right? Just bring it go to the other side. So accept 2x here, accept the 2x here. So minus minus with so here I still have y, right? So I have x dy dx minus with 2y dy dx. Then I still have positive y here, right? I have positive y here. X dy dx negative 2y dy dx plus y. So equal to 2x. My purpose here is to try to adapt to what is required by this function here. So then later, I'm going to rearrange this one to be x minus 2y, x minus 2y, dy dx as I factor out the dy dx, right? Then plus with y equals to 2x. Okay, so from here, I'm going to rewrite this whole thing, but I put this one on the left-hand side now. So x minus 2y dy dx, right? X minus 2y dy dx plus y equals to 2x, right? Equals to 2x. So this is my first order differential. This is only first order here, dy dx. So to get the second order, I have to differentiate this function here, implicit function here. So for one more time, right? So I differentiate with respect to x. So be careful about this thing. So now as you differentiate this whole thing, you differentiate 2x, you have 2, right? Differentiate 2x, you have 2. Differentiate y, you have dy dx. You know that differentiate 2x, you have 2. Differentiate y, you have dy dx. How about this part here? Right? This part is a product. It's a product. Can you see that? The bracket x minus 2y. The bracket x minus 2y, this whole thing as your u. And this whole thing as your v. So it's a product form. So you have to apply product rule for this part here. So now u v prime. So I have u v prime plus with v u prime. So u x minus 2y v prime, differentiate dy dx first derivative, then you differentiate again, you are getting second second derivative, right? So let's continue. This is your u v prime, right? U v prime. Now v u prime, v u prime. So differentiate x. Differentiate x, you have 1. Differentiate 2y, negative, you write negative, negative 2y. So you have 2 dy dx. So you have done complete to applying u v prime plus with v u prime plus with dy dx equals to 2. So I just need to rearrange this whole thing, right? Just need to rearrange this whole thing here. So I writing x minus 2y d2y dx2 dy dx2 plus with expanding this, you have dy dx, right? Dy dx multiply 1 multiply with 2. Dy dx multiply 1, you have dy dx minus 2 dy dx and dy dx. This is dy dx to the power of 2. It's not d2y dx2. It's not differentiating. They are power of 2. Dy dx multiply with dy dx plus with dy dx equals to 2. So I think just a little more, I can reach this final something that I want to prove. So now I'm going to prove this thing. Alright, let's look at this line here. Let's look at this line here. So let's look at this line here. So you will have x minus 2y d2y dx2, right? So you can see that dy dx plus with dy dx, dy dx plus with dy dx, you will have dy dx plus with dy dx. So I combine this dy dx to this dy dx, I will have 2, right? 2 dy dx minus 2 dy dx square. So from here you can see that you are actually factorizing the 2 dy dx, right? So it means that 2 dy dx and you're factorizing the 2 dy dx. So you're getting positive 2 dy dx. As you factorize 2 dy dx, this one you are remaining in the bracket, you have 1. And minus, you have factorized 2 dy dx. So because of degree of 2, you still have 1 more dy dx. You have still 1 more dy dx to the power of 1. So finally, equate it to the right hand side, so which is 2. So if you look at this, if you look at x minus 2y d2y dx2, x minus y d2y dx2 plus 2 dy dx, 1 minus dy dx equals to 2. Finally, you have shown that this is true, right? We have shown this is the second order differential equation from this implicit function here. Alright, that's all for this example.